Hi, you guys. This is Miss Gariano, and I thought it might be helpful for some people to have an example that they can look back to as either they're trying to complete homework assignments to review for the quiz or the test or the final exam at the end of the semester. So let's look at an example of how we can graph a rational function. So this is kind of a whole enchilada sort of graphing where we're going to look at vertical asymptotes, holes, horizontal asymptotes, and the x and y intercepts. So we have 4 steps to remember when we're trying to sketch the graph of a rational function. Step 1 is to find where the denominator equals 0 so that we can find the points of discontinuity. Step 2 is to take those points of discontinuity and determine whether they are either holes or asymptotes by looking at the factored form. Step 3 is to find our x and y intercepts, and then step 4 is to find the horizontal asymptote if there is one. Alright, so let's start in with step number 1. So we want to find where the denominator equals 0. So we're going to take our denominator, which is x cubed minus 4x, and set it equal to 0. So I notice off the bat that we have a common factor of x in both of these terms. So I'm going to factor out an x. So I am left with x squared minus 4 equals 0. And inside the parentheses here, I can further factor it because it's an x squared, and we have the difference of 2 squares, which you might recognize. Or we can think of this as being x squared plus 0x minus 4. So we want to think of something that multiplies to give us negative 4 and adds to give us 0. So if we use a negative 2 and a positive 2, that will give us what we are looking for. So we can factor this as x times the quantity x minus 2 times x plus 2 equals 0. So we actually have 3 places where we have discontinuity. Here we have discontinuity at x equals 0, at x equals 2, and x equals negative 2. So we have 3 places where we have points of discontinuity. So then our step 2 is to figure out whether these points of discontinuity are holes or asymptotes. So in order to do that, we need to look at the factored form of our equation here. So I can take this and think of it as 4 times x, right? I mean, I think this will help us to see something, which is why I wrote it this way. But basically, we can't really factor it beyond what it is here. However, we can factor the denominator, as we saw right here. So I'm going to write it in factored form, which is x times x minus 2 times x plus 2. So I see that we actually do have a common factor of x in both the numerator and the denominator, which tells me this guy, x equals 0, is going to be a whole. And we cannot find a common factor of x minus 2 or x plus 2 in the numerator, which tells me these 2 places are vertical asymptotes. Alright, so for sake of space, I am actually going to go ahead and plot these 2 places on our graph. Sorry, I'm going to label this so that I can find it because I'm going to have to be playing with my layers so we have space. Alright, so what I am going to do is I have a hole at x equals 0. So what I'm going to do to figure out the actual location of our hole is I am going to come up to this equation. I'm going to rewrite it without the x's that I canceled out. So 4 over x minus 2, x plus 2, and oh, I guess, oh no, we'll be okay. So then I'm going to plug in my 0, x equals 0, because that's where my hole is, into this equation. So I get 4 over, if I plug a 0 in here, I get a negative 2. If I plug a 0 in for this x here, I get a positive 2. So I get 4 over negative 4, which is just negative 1. So I know my hole is at the point 0, negative 1. So I can plot my hole down. 0, negative 1. This is my hole. Oops. Here's my hole. All right. Then we want to have the asymptotes. So I am going to use this color here. Here we go. To signify my asymptote. So I have one at x equals 2 and x equals negative 2. So here are my vertical asymptotes. All right. So now that I've gone through my first 2 steps, I'm going to move on to my second 2 steps. All right. So for step number 3, we want to find the x and y intercepts. So to do that, we are going to, well, let's see, to find my y-intercept, I'm going to let x equal 0. So I'm going to take this equation here and I'm going to let all the x's be 0. So I get y equals 4 times 0 over 0 cubed minus 4 times 0. So I get a big fat 0. But also, well, I'm getting 0 divided by 0. We cannot divide by 0. So there actually is no y-intercept, which we could also know by our previous work where we found our points of discontinuity. X equals 0 was one of them. So if you recognize that, you don't even have to look for the y-intercept. Then to find the x-intercept, I'm going to let y equals 0. And we only care about the numerator here because we don't want the denominator to end up being 0. So I'm going to say 0 equals 4x, which means if I divide by 4, I get 0 equals x, which we already figured out that x equals 0 from up here is it's a no-no. It's a point of discontinuity because if we plug the 0 in our denominator, we get 0 out, which we do not want. So there is also no x-intercept. No x-intercept. All right, so that's pretty simple. There's nothing we need to add to our graph because there's no x-intercept and there's no y-intercept. If it had been there, we would have thought of it as being the origin, but again, it's not. All right, which means we can move on to step number 4, which is finding the horizontal asymptote. So let me scooch this up a little bit. So step 4, we want to find the horizontal asymptote, if any. So what I'm going to do then is I'm going to find the degree of the numerator and compare it with the degree of the denominator. So the degree of the numerator is equal to this guy here, which is a understood 1. And the degree of the denominator is equal to this here, which is our 3. So since the degree of the denominator is larger than the degree of the numerator, that gives us the case where our horizontal asymptote is at y equals 0. So I can go ahead and plot that on my graph. Here we go. So here's what we had for our graph, and I'm going to add in a horizontal asymptote along y equals 0, which is this line here. So let me get kind of an obnoxious color going on so maybe we can actually see it. And let's make this like 4 point. All right. So horizontal asymptote right here. So that guy is going to be our horizontal asymptote that we are going to avoid. So we've gone through our 4 steps, which is awesome, but we have this value here that we know we're going to approach but never actually touch. So we know that this center part is going to do generally something like this. But we don't have enough information for the left side or the right side of these vertical asymptotes. So let's go ahead and let's find some data there. So let's pick some values. So I want to pick something like -3 and +3 to plug in. So if I let x equal -3, I get y is equal to 4 times -3 over -3 cubed minus 4 times -3. 4 times -3 is -12. -3 cubed is going to be a -27. And then -4 times -3 is a +12. So we get -27 plus 12 is going to give us -15. So -12 over -15 is going to be a positive 4/5. So I know that over here I'm going to be at a positive, almost a +1, so right in here. So that tells me my curviness is happening up in this quadrant over here. Then I'm going to pick this value of 3 because that's to the right of my other asymptote. So if I let x equal 3, I get y is equal to 4 times 3 over 3 cubed minus 4 times 3. So I get 12 over 27 minus 12, which is going to be 12 over, okay, that worked out nicely. 12 over 15, which we already know is 4/5. So again, we are almost at 1 there. So now that I have an idea of where my graph is going to lie, I can go ahead and draw in the graph following the lines of my asymptotes. I'm just going to approach them but never cross them. And we could technically cross the horizontal asymptote here, and we would know if we had ever crossed it because when we went to go find our y-intercept, our x-intercept, we would have gotten more than one value or something so that we would know it would cross or touch it, but we didn't, so we know it's, in this case, we're never going to cross our horizontal asymptote. So it's safe to just follow the grid lines. All right, so this tells us the general shape of our graph of the rational function 4x over x cubed minus 4x. So here we have two vertical asymptotes, one horizontal asymptote, and our hole. So it kind of encompasses everything that we might see when we would find, or when we'd be graphing these. So I thought it would make a good example. So I hope this was helpful and that you can look back at this example for whatever your needs might be. All right, have a good night.